This is SpaceTime Series 24, Episode 25. Coming up on SpaceTime, astronomers discover a space hurricane for the first time. Another spectacular SpaceX Starship explosion, this time after a successful flight test. And Rocket Lab's Electron about to get a big brother. Enter the Neutron rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered what they're calling a space hurricane high up in Earth's upper atmosphere. The celestial cyclone, reported in the journal Nature Communications, was detected in satellite data in the ionosphere and magnetosphere, spinning in an anti-clockwise direction with multiple spiral arms and lasting almost 8 hours before gradually dissipating. The observations, based on 2014 satellite data, allowed the authors to build up a three-dimensional image of the event, showing it to be a 1,000-kilometre wide swirling mass of plasma several hundred kilometres above the North Pole, raining down electrons. The data suggest a surprisingly large energy flux and momentum deposition into the Earth's ionosphere, despite otherwise extremely quiet geomagnetic conditions. Until now, scientists weren't even sure that space plasma hurricanes existed. Tropical cyclones are characterized by a low-pressure center or eye, surrounded by extremely powerful winds and flow shears with a spiral arrangement of towering clouds and heavy rains. They're the most powerful storms on Earth. The study's lead author, Professor Qinghai Zhang from the Shandong University, says tropical cyclones are associated with huge amounts of energy in the lower atmosphere. And these newly discovered space hurricanes must be created through an unusually large and rapid transfer of solar wind energy and charged particles into Earth's upper atmosphere. Plasma and magnetic fields in the atmospheres of planets exist throughout the universe, so the findings suggest that these space hurricanes should also be fairly widespread. Astronomers just simply haven't looked for them until now. Of course, scientists have seen cyclones lower down in the atmospheres of Jupiter, Saturn and Neptune, which are more similar to tropical cyclones on Earth. And they've also identified so-called solar tornadoes, monstrous formations of solar gas swirling deep inside the Sun's atmosphere. However, these newly discovered space hurricanes haven't been seen anywhere before. But needless to say, scientists will start looking for them now. This is SpaceTime. Still to come, Space Machines Company secures its first contract for its new Optimus 1 orbital transfer unit, and another spectacular SpaceX Starship explosion. The difference is this one occurred after a successful flight test. All that and much more still to come on SpaceTime. Space Machines Company has secured a contract for its new Optimus 1 orbital transfer unit. The Adelaide-based company will provide in-orbit transport services for Thibault International's proposed bushfire detection satellite. It'll launch aboard the maiden flight of Gilmour Space Technologies' new Ares rocket, which is slated for March next year. Thibault are planning a constellation of small satellites using infrared sensors to provide early warning of bushfires from orbit. The company's technology was recently put to the test aboard one of the GOES satellites during the California bushfires. Space Machine Company's 35-kilogram Optimus 1 space taxi will transfer a dedicated Fireball satellite into its final orbit. Space Machines Company founder and CEO Rajet Kulshrestha says Optimus 1 is far more than just an upper-stage kick motor. He says the company's planning a range of space tugs capable of transporting vehicles ranging from mini-satellites through to multi-ton spacecraft into low Earth and geostationary orbits as well as cislunar moon orbits using a range of liquid-fueled and Hall-effect ion thruster propulsion systems.
We started the company about 2 years ago, and the initial premise of the company was that we were thinking about in-space manufacturing and assembly and how we could assemble and manufacture products and infrastructure in space. And as we thought more about it and looked at the history, we realized that one of the biggest growth of industry has been logistics and transportation. And, whether that's been land transportation or rails and ocean or aviation, there's been a common trend, which has been the efficiency of long-range travel with larger transfers of mass, things like point-to-point. And then there's been this last-mile connectivity in transportation. And so when we looked at the market, we saw that, there's a number of companies, SpaceX, Blue Origin, a lot of smaller launchers. They've been working in building the access to space. Our natural thinking at that point was, how do we start to complement that with in-space transportation? How do we start to build the capability for satellites and payloads to get more mobile in space? And that was the premise of the services that we started thinking through. And so our current platform, which is called Optimus, is a range of vehicles we're designing and building that will help customers across that last mile. So the rockets get you to orbit, and then our vehicles will provide that transit to final destination, whatever that might be, whether that's low Earth orbit or geosynchronous or lunar or Mars.
So are you already attached to the payload when it leaves Earth, or are you up there waiting for it to arrive at a specific orbit and then you grab the payload and take it to its final location?
I think the ultimate vision is to have a number of vehicles in parking orbits waiting for customers to arrive. But I think at the moment, the first few versions will be customers being attached to our vehicles and going up there. And we're starting to think through how do we extend lives of those vehicles as they get up there. But the ultimate vision is a transportation network that's multiple of these vehicles invading in different orbits.
So initially, it's basically a kick motor you're providing. And in the long run, you hope to be on station in orbit to move from one orbit to another.
Kick motors have optimized design for circularizing orbits. They've been built to be compatible with whatever rocket architecture is underneath. Our vehicles are being designed to be compatible with most launchers out there, so the larger ones like Falcon 9 and Starships that are coming down the road, but also smaller launchers like Gilmore and Rocket Lab.
What's your timeline at this stage?
We've got a first flight Optimus 1, which will basically qualify most of our subsystems, which is going up on Gilmore Space's first flight, the Eris-1 in March 22. And we've got a second Optimus 2 flight planned for December of 22, which would be limited commercial flight with some customers on it.
Will both of these be one-shot operations, or once you've got your vehicle up there, will there be enough fuel on board to handle other customers once you get to orbit?
The first one is going to be propelled by solar electric, so it'll be a Hall effect thruster. And, given the efficiency of, electric thrusters, we'll have enough propellant to help multiple customers and carry out additional mission objectives. We'll also have a chemical, which is locally Australian built at the moment and being designed, which is customized to a vehicle like that. So we're also building a chemical capability. And our objective has been to really harness the liquid methane, liquid oxygen economy that's been built by the larger players in the market. So with Blue Origin and SpaceX both investing heavily in liquid methane and liquid oxygen engines.
And also United Launch Alliance as well. Then your Vulcan will be liquid methane, liquid oxygen.
Exactly. So our view has been that there's going to be infrastructure being built for those sort of propellants. And so we're building smaller scale complementary propulsion capability to leverage that.
You say you're looking at not just Earth orbit, but also Mars and lunar orbits as well. How far does it go?
So look, I think at the moment, the current mission profile in terms of we've got sufficient delta V to get to Mars, carrying about 25 to 30 kilos with the smaller vehicle that we're designing, and then up to 100, 150 kilos for the larger vehicle that we're designing.
Describe your Optimus vehicle to us.
We've got a propulsion module that fits either as a spacecraft in itself and then has a payload adapter on top and can carry CubeSat and SmallSat, and also solar panels where we're using solar electric propulsion. So it's basically a modular approach with two components, a core propulsion module and service module, and then a payload module that allows different types of payloads to be plugged on.
In the last few months, we've seen, I think it was United Launch Alliance, launch a module into space which is designed to extend the life of other spacecraft. In this case, they attached it to a telecommunications satellite, and it basically extended its lifespan by providing it with additional fuel, and it's going to remain part of that spacecraft for the next few years before it moves on to another spacecraft. Is this the sort of thing you're also looking at, extending the life of existing satellites?
Absolutely. So, the kind of missions we're supporting fall in 4 categories. One is really just transit and transfer, so from one orbit to another, or one orbit to a higher orbit, or to Lunar or Mars. The second part of it, orbit servicing and maintenance, which is what you just described, is how, and that's one key part of the vehicle we're designing, where the power, data, and communication interfaces, we're standardizing ports so that we can add things like the life extension, satellite life extension modules that can dock with existing satellites and extend their life. We're also looking at debris management. So how do we attach these vehicles to existing satellites that have gone out of use and help them get out of Earth's vicinity faster, whether they get pushed up to graveyard orbits or burn up on reentry. The third part is obviously deep space exploration. How do we start to look at smaller, more cost-effective and frequent deep space missions? And finally, there's been a large investment both in the U.S. And in Europe around infrastructure deployment with the Lunar Gateway. There's a number of companies starting to look at manufacturing in space. So how do we help in that process of transporting raw materials between different orbits or between 2 different bodies?
The infrastructure needed just to operate something in space, running it from a computer on a desktop might be the ideal, but it's not feasible as yet, is it?
Look, I think it's not feasible yet because there is a lot of space industry has been a bespoke industry. So, we've operated mission by mission. And I think what's changing is that it's becoming a product-oriented industry. And as that happens, the interfaces, hardware, software are starting to go through a process of standardization. As that happens, that vision where you could sit on a computer like Amazon Web Service and plug in the type of service satellite you want and what orbit you want and press go, that starts to become a plausible future.
But you still need ground stations around the world to talk to that satellite, or do you just wait till it comes to you?
No, look, I think absolutely. I think ground stations is a major area of investment. I think we're already starting to see that as more and more space objects are going up, there's a very heavy pressure on ground stations and the ability to track. So I think both ground stations and then also putting communication relays in space so that we can actually redirect traffic. So satellite-to-satellite communication, I think, is going to help a lot. Also looking at how do we use existing satellites as, we already do this on land with ad hoc mobile networks. How do we start to create a network of satellites sharing some of the bandwidth? Now, there's geopolitical issues with that, but I think there's already work being done to see how we could leverage that.
I guess the other end of the whole story too is developing the vehicle you plan to use. We haven't heard much about the Space Machines company so far. Have you been developing a vehicle? If so, where? What stage are you at now? You want to launch in a year from now?
We're currently based in Sydney, so we've got a corporate office in Adelaide. We're based in Sydney. Sydney is where we're designing, developing, and manufacturing the vehicle. And so we're based out of Mascot at UTS Tech Lab. So we've got a very smart and motivated group of engineers working here, and we've got a complementary team back in Bangalore in India, where there is a lot of more basic R&D, and there's some experience also providing capability to fly on ISRO's PSLV and SSLV. We already passed some of the key engineering milestones, so we're hoping to start to put the flight model together in July.
That's Rajit Kulshrestha, the CEO and founder of Space Machines Company. And this is Space Time. I'm Stuart Gary. Still to come, another spectacular explosion for SpaceX's Starship, but this one was different. It followed a successful test flight. And Rocket Lab's Electron rocket gets a big brother, introducing the Neutron rocket. All that and much more still to come on Space Time. The SpaceX SN10 Starship prototype test article has exploded in a spectacular orange fireball less than 10 minutes after completing a successful test flight from its South Texas launch facility. Starship had undertaken a spectacular 6-minute 20-second flight, climbing vertically to an altitude of 10 kilometers on its 3 Raptor engines before hovering and performing a number of precise in-flight maneuvers and then transitioning into a horizontal position and descending back towards the ground before successfully returning to a vertical position for final touchdown.
QS 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. We have liftoff.
Acknowledge software.
SC2, please prepare for section 35. OSC, FC1, LVN.
T plus 30 seconds. Starship 10 has liftoff. It's headed to 10 kilometers on its test flight from Boca Chica in Cameron County, Texas. Coming up on T plus 2 minutes, we're getting ready to transition from 3 engines to 2 engines firing on Starship. We'll be shutting 1 engine off. That's intentional. T plus 3 minutes and counting. Starship coming up on 8 kilometers altitude. We're getting ready to shut down the 2nd engine. This is intentional. Coming up on T plus 4 minutes. We're at 10 kilometers. We've gone into the hover. We're still being powered by the single Raptor engine. T plus 4 minutes and 40 seconds. Starship has transitioned. It's flipped to the horizontal mode, beginning the descent back to the landing zone. Coming up on 5 minutes, 45 seconds. We're down below 2 kilometers. We're preparing to light 3 Raptor engines to begin the flip sequence that'll culminate with landing on the landing pad in Boca Chica. 3rd time's a charm, as the saying goes. We've had a successful soft touchdown on the landing pad that's capping a beautiful test flight of Starship 10. As a reminder, the key point of today's test flight was to gather the data on controlling the vehicle while re-entering, and we were successful in doing so. We had a nominal ascent. We had the maneuver to place Starship horizontal when we reached 10 kilometers, right on time. And then during the subsonic entry, it appears we had good control of the vehicle using the front and aft flaps. And as we approached the landing pad, we successfully lit the 3 Raptor engines to perform that flip maneuver. And then we shut down 2 of them and landed on the single engine as planned. A beautiful soft landing of Starship on the landing pad at Boca Chica. The Texas team has several more suborbital test vehicles in build, with number 11 ready to roll out to the pad in the very near future.
It looked like a spectacular success. However, things were not as good as they seemed. During the landing, 3 of the 6 landing legs failed. They just hung there and wobbled as the thing descended. And they provided no support at all once the SN10 test article reached the ground. That resulted in the spacecraft having a noticeable tilt once it came to rest. Then, almost 10 minutes after touchdown, there was a sudden puff of black smoke near the base of the rocket. At the same time, observers realized that the nose cone had appeared to crinkle. That suggests a major internal structural failure. And then a massive explosion, blowing the vehicle hundreds of meters back up into the air as it ripped apart. Here's how the Everyday Astronaut website described what happened.
Oh, God, it just blew up. It just blew up. It just blew up. What? 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 What just happened?
The previous SN8 and SN9 test articles also ended up in explosive failures, but that happened after they had landed too heavily. This explosion was very different because of the sequence of events leading up to it. The full investigation will determine what really happened. Originally called the BFR or Big Falcon rocket, Starship is the culmination of SpaceX boss Elon Musk's dream to develop a fully reusable super heavy lift spacecraft capable of carrying 150 tons of people and cargo into orbit, and 100 tons on missions to the moon and on interplanetary journeys across the solar system. Musk says he sees Starship very much as a colonial transport system. Technically, Starship is the upper stage of a 2-stage launch system. The 230-ton first stage, called the Super Heavy, is 68 metres long, 9 metres in diameter, and constructed out of stainless steel. It'll be powered by 37 liquid methane and oxygen-propelled Raptor rocket engines, providing 72 meganewtons or 16 million pounds of thrust. The 120-ton upper or Starship stage is 50 metres long, also 9 metres wide, and will be powered by 6 liquid methane and oxygen propellant Raptor rocket engines, 3 configured for atmospheric operations and 3 for the vacuum of space. At full thrust, they'll deliver approximately 12,000 kilonewtons or 2,600,000 pounds of thrust. Starship is equipped with its own retractable landing gear, allowing rocket-assisted vertical landings. That was one of the things they were testing prior to this latest explosion. SpaceX plans on using Starship to replace the company's existing Falcon 9 and Falcon Heavy launch systems, as well as its Dragon capsules, with the first flight slated for 2023. This is SpaceTime. Still to come, Rocket Lab's Electron rocket gets a big brother, and later in the science report, Johnson & Johnson's new single-dose COVID-19 vaccine gets FDA approval. All that and much more still to come on SpaceTime. New Zealand-based company Rocket Lab has unveiled plans for a new bigger rocket which could be flying by 2024. The new 40-metre tall two-stage Neutron rocket will be designed to carry 8 tons of payload into low Earth orbit. It'll also be capable of carrying 2 tons into lunar orbit and 1.5 tons on interplanetary missions to Mars or Venus. The Neutron will build on the success of Rocket Lab's existing Electron launch vehicle, which carries up to 300 kilograms into low Earth orbit and has, in the short time it's been flying, become one of the busiest launch systems in the world, with flights launching from its New Zealand spaceport almost every month. The company says the new Neutron rocket will provide constellation deployment capability, placing multiple satellites into a range of different orbits, or it could be used to launch a single large satellite into low Earth orbit. The new launch vehicle will fly from NASA's Wallops Island flight facility on the Virginian mid-Atlantic coast, with the first stage being reusable and landing on an ocean platform. Rocket Lab have been building an Electron launch pad at Wallops Island to complement its existing New Zealand launch complex. It's also been developing an Electron core stage retrieval method, which will see the Electron first stage guided back to Earth by parachutes following a launch, and then collected in mid-air by helicopter for refurbishment and reuse. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Johnson & Johnson's new single-dose COVID-19 vaccine has been approved for use by America's Food and Drug Administration. Like the Oxford AstraZeneca vaccine, the Johnson & Johnson product uses an adenovirus to prime the body's immune system for COVID-19. Trials in the United States, South Africa and Brazil show that it's more than 85% effective in preventing serious illness and 66% effective overall when moderate cases were included. Now that's not as good as the 95% being achieved by the mRNA-based Pfizer and Moderna vaccines, but it is better than the 70% efficacy of the adenovirus-based Oxford AstraZeneca vaccine. It's also very similar to the protein-based Novavax, which has an efficacy of 89% and which has been found effective against both the UK and South African strains. But the Johnson & Johnson vaccine's big advantage isn't just that it can be stored in a regular fridge, but that you only need a single dose. Over 2.6 million people have now died from the COVID-19 virus, with another 116 million infected since the deadly disease first emerged in Wuhan, China, and spread around the world. Scientists are warning that the Gulf Stream is now the weakest it's been in 1,000 years. The Gulf Stream acts like a giant conveyor belt in the Atlantic Ocean, carrying warm surface water from the equator up north and sending cold, low-salinity deep water back down south, in the process warming much of North America and Western Europe. The new findings, reported in the journal Nature Geoscience, are based on detailed studies of ocean sediments and ice core samples dating back hundreds of years, which were used to reconstruct the Gulf Stream's long-term flow history. The scientists from Ireland, Britain and Germany show that for the past decade, the Atlantic meridional overturning circulation system has been weak. They found consistent evidence that its slowdown in the 20th century is unprecedented over the past millennium and is likely linked to human-induced climate change. It follows on from previous research, which found a slowdown in the ocean current of around 15% since the mid-20th century. This now combined data provides a continuous picture of the Gulf Stream over the past 1,600 years. The study shows that it's all been relatively stable until the late 19th century. But with the end of the Little Ice Age around 1850, the ocean currents began to decline, with a second more drastic decline following in the mid-20th century. And its weakenings also generating a so-called cold blob in the North Atlantic, just as predicted by climate change models. Archaeologists at Pompeii have discovered an intact ceremonial chariot at an illegal dig site near Naples. The chariot, with its iron elements, bronze decorations and mineralized wooden remains, is in an excellent state of preservation and is being described as an exceptional and unique discovery, which has no parallel in Italy so far. It was found parked in the portico of a stable in the ruins of a settlement north of Pompeii, beyond the walls of the ancient city. The remains of 3 horses were previously discovered at the site. The eruption of Mount Vesuvius in the year 79 destroyed Pompeii, but the chariot was spared when the walls and roof of the structure it was in collapsed, and it also managed to survive looting by modern-day antiquity thieves. Well, you may recall it was just last week we were telling you that coffee consumption was good for heart health. But now new research points out that you shouldn't have too much of a good thing, with scientists warning that long-term heavy coffee consumption, that means 6 or more cups a day, could increase your risk of cardiovascular disease. The findings, reported in the journal Clinical Nutrition, are based on data from 362,571 participants in the UK, aged between 37 and 73, examining phenotypic associations between coffee intake and plasma lipid profiles, including low-density lipoprotein cholesterol, high-density lipoprotein cholesterol, total cholesterol, triglycerides, and apolipoproteins. The authors found that habitual coffee consumption contributed to a high lipid profile, increasing your risk of heart disease. Scientists focused on a potential cholesterol-elevating compound in coffee beans called cafestol. Cafestol is mainly present in unfiltered brews, such as French press, Turkish and Greek coffees. But it's also found in espressos, which are the basis for most barista-made coffees, including lattes and cappuccinos. The good news is there's little cafestol in filtered or instant coffee. A new study shows that 40% of Australians still wrongly believe that alternative therapies can cure cancer. The problem persists because of the misinformation feeding to the public sphere through unchecked sources like social media and the internet. Tim Mendham from Australian Skeptics says people affected by cancer are especially vulnerable, becoming targets for those looking to sell products or miracle cures.
Yeah, the Cancer Council did a survey that looking at Australians' attitudes towards cancer and the causes of cancer and a few what they regard as cancer myths, or at least sort of areas that are not quite sure. One of the results was that about 40% of Australians believe that alternative therapies can cure cancer, which is highly, obviously, unfounded, that they can, but actually they can't, because anything alternative really lacks evidence to support its cases. So that's a concern that people who have cancer, obviously people who have cancer can get very desperate, understandably, and if normal medicine can't find a cure or a treatment, they might turn to other areas. So that 40% might be wishful thinking. Unfortunately, that's as far as it goes.
I guess the other problem there is that you have people who are willing to go for the alternative treatment first before trying scientifically proven methods, and that's the real worry, isn't it?
That's right. That's exactly right. And that is what is happening. I mean, you're finding certain groups are regarding themselves or trying to sort of picture themselves as primary healthcare suppliers. In other words, that's the place you go to first. The chiropractic industry is definitely doing that. They're quite publicly saying they want to be seen as the first port of call, and you'll soon find that some naturopaths and people like that are also pitching themselves in the same way.
Even the occasional ex-cook.
That's right, yeah, they're the highly qualified people of the world. Yeah, there's a lot of opportunities there for people to be misled, and unfortunately alternative therapies are by and large in that category. Other myths that they looked at was that 8%, not a huge number, but 8% don't realise you can get skin cancer even if you don't get sunburn, because you can actually get cancer from reflected light as much as you can from direct sunlight. You can get it sort of in places where the sun never shines. as anyone with melanoma can tell you. So it's not just necessarily that you have to get sunburned to actually get skin cancer. Another one they looked at was 2 in 3 people agree that animals can sniff out cancer.
Now, there's some truth in this one, isn't there? I mean, haven't they proven that dogs can sniff out some cancers?
There's cases where it seems to be, but the suggestion by the Cancer Council is that the studies have been pretty limited. From a scientific perspective, there's certainly a lot of anecdotal evidence.
Oh, yeah, the famous cat that will always sit next to the person who's going to die that night.
That's right. Yeah, I mean, there's not just that, but there's dogs especially, which people are saying that they can sniff out cancer. And there have been tests done with dogs in sniffing into funnels and that sort of thing, whether it's sort of cancerous tissue or something, to see how they react. But at the moment, they're saying that that's a bit interesting, perhaps potential, who knows, but definitely not necessarily scientifically cut and dried.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.